Hey everyone, it's that math magician, and on this video we're going to take a look at an introduction to the sine ratio. Now hopefully we are familiar with tangent. Tangent is a ratio we discovered a couple of videos ago where we were looking at the relationship between a slope triangle and the side delta y and the side delta x, right? The vertical and the horizontal. But we're going to see how sometimes when we're dealing with a right triangle, that the right triangle example that we have, tangent won't work. And so we want to now learn a new trig ratio, it's called sine, and how that can help us solve for an unknown side of a right triangle. So we see here that we have our right triangle, we have our reference angle of 23 degrees. We do not know the height of this triangle, it's labeled here as x, but we do know that there is an hypotenuse of 14. Now, if I were to try to set up tangent for this problem, we're going to see that we quickly run into an issue. So let's just do it and see it, and then we'll understand why tangent doesn't work here. When I try to set up my tangent ratio, I still write the word tan. Tangent of my angle here, my reference angle, is 23 degrees, and that's equal to our fraction. And our fraction is normally delta y over delta x. Now in the previous video, I mentioned to find delta y, you just start at your reference angle, you draw an arrow going to the opposite side, and that's how you identify your delta y. But in this case, I'm just going to call it the opposite side here. So our opposite side is x. I would put x on the top of my fraction as the numerator. And then for tangent, I'm interested in delta x, or this base of the triangle. Now you're noticing that I don't know the length of the base of that triangle. Delta x there is unknown, so there's nothing that I can put into my tangent ratio. Since I don't have a value there, I could label it a different variable, such as y. And you see that when I create my tangent ratio, I have an x and a y variable, and now I'm unable to solve for just one of those. This is why tangent is failing for this problem. Tangent doesn't work if your delta y and your delta x are both unknown values. Now what's nice about this problem here, let me go ahead and write a big X over tangent because tangent's not going to work here. What's nice about this example is that they do tell us that the hypotenuse here is 14, right? If that 14 had been on the bottom here, we definitely could have used tangent, but that 14 is there as our hypotenuse. Remember that hypotenuse is just that diagonal side of the right triangle. If it helps you to remember this, the hypotenuse is always across from your right angle. So we have our hypotenuse, we have our opposite side of x, and we know our reference angle. This is where we want to introduce the sine ratio. The sine ratio, let me go ahead and write it out as a formula first, and then I'll show you how we'll use it with our problem. For when you're using the sine ratio, we abbreviate it SIN, so it's not going to be pronounced sin, okay? We're not in church, we don't use sins here in math. Instead, we pronounce that as sine. And it's going to be sine of our reference angle theta, whatever that angle happens to be. Now that's equal to, again, a fraction, but this is not tangent. So we're not going to have delta y over delta x, but it is familiar with tangent. If you notice here with tangent, we use delta y, or that opposite side from our reference angle. That still is going to hold for the sine ratio. We're going to include the opposite side as the numerator, just like with tangent. But for the denominator, we end up using the hypotenuse side. So that is our generic formula for the sine ratio. It is sine of your angle, whatever your reference angle is, equal to the fraction of the opposite side over the hypotenuse. So now that we have a formula, we can now solve this problem here using sine. So let's go ahead and do that. I'm going to write sine of my reference angle. My reference angle that I'm using here is 23 degrees. So I'm writing sine of 23 degrees equal to a fraction where it's the opposite side on top, the hypotenuse on the bottom. So my numerator here is the opposite side, which is x, over the hypotenuse side as my denominator, which is 14. Now I have an equation here where I have just one variable and I can solve now, very similar to the way that we solve a tangent problem. So to solve this, I'll just put that left side over 1. I will cross multiply and I will solve for x on its own. So I'm going to cross multiply. Let's see, 1 times x, that becomes x equals, I'll cross multiply the other two. We end up with 14 times sine of 23 degrees. So I'm going to write that out as 14 times sine of 23 degrees. And that right there is what I want to enter into my calculator. I'm going to enter that whole expression, 14 sine 23, and I will get a nice approximation for that value of x. So let me go ahead and use my calculator. I'm going to use the free online calculator called Desmos. They have a nice scientific calculator that's free to use, and it's very helpful to solve problems out like this. So let me go ahead and enter that. And we see there that our value for x, which is 14 times sine of 23 degrees, ends up being 5.470. Remember, when we're working out these problems, look at that, I quickly forgot, 5.470. We always want 3 numbers after the decimal point. That is why we have the sine ratio. We're now able to solve this triangle when tangent fails. Tangent is nice. We like tangent. It works well when it works, but sometimes it'll fail. And when it fails, we can use our sine ratio. But remember, the sine ratio only works when we have our opposite side and our hypotenuse side. It's that math magician, and I'll see you on the next video.